Now student, we shall discuss about electric motor. So what we are going to discuss now? Electric motor. That is electric motor. Student, electric motor is a device which converts electrical energy to mechanical energy. It is a device that converts electrical energy to mechanical energy. Student, electric motor is used to run many electrical appliances such as machines, fans, refrigerators. Now student, electric motor, a commonly used motor, uses direct current, so it is called a DC motor. So student, electric motor is a device that converts electrical energy to mechanical energy. A commonly used electric motor uses direct current. So is called DC motor. Now student, as commonly used electric motor uses direct current, that's why it is called DC motor. Now student, in this section of this chapter we have to discuss about the principle of DC motor. We have to discuss about the construction of DC motor, and we have to discuss about its working. Of DC motor. So student, we will start with the principle. Student, it is based on the principle, or an electric motor is based on the principle that when a rectangular coil is placed in a magnetic field and current is passed through it, due to the forces which are equal and opposite, and they are acting on the two opposite arms of the rectangular coil, they rotate it continuously. So student, it is based principle an electric motor is based on the principle that when rectangular coil is placed in a magnetic field, and current is passed through the coil two equal and opposite forces acting on the two sides, to opposite sides of the coil tends to rotate it continuously. Now student, what do you mean by these opposite forces which are trying to rotate the coil? Student, see, if I say the two forces are acting on this chalk piece, one is towards right and one is towards left. Student, if these two forces are equal, the position of this chalk piece remains the same. If the force which is acting towards right is more, then it will move to this side. If force which is acting towards left is more, it will move to this side. But if these two forces are equal, then the position of the chalk remains the same. Now student, what if these two forces are equal but they are acting in such direction that one force is acting here and the other force is acting along this direction? Then student, this chalk piece will start rotating like this. Similarly, in the case of rectangular coil, student, two opposite forces are acting on the opposite sides of the coil which are trying to rotate the coil or which tends to rotate it continuously. Similarly student, for example, when you open a tap, actually you apply two forces which are in opposite directions. So they tends to open the tap. Similarly student, in the case of rectangular coil which is placed in the magnetic field, two equal and opposite forces are acting on the opposite sides of the coil which tends to rotate it continuously. Now students, so far we have discussed about the principle of DC motor. Now let's discuss about the construction of electric motor. Now student, we have to discuss about the construction of electric motor. See here, this is the diagram of an electric motor. Student, it consists of an armature which is also known as rotor. Student, armature is a rectangular insulated copper wire which is wounded over a soft iron core. Student, this is known as armature. Now student, this rectangular coil is placed between the two poles of a horseshoe magnet, and student, this armature is connected with commutators. Student, these two are commutators. The function of commutators is to reverse the direction of the current each time when coil reaches or passes the vertical position. Similarly student, these two are the brushes which connect this battery to the commutators, or student, we can say that the current passes through the rotor or through the armature of this rectangular coil via these two carbon brushes. Now student, let's write down the functions of these parts. Student, armature, it consists of a rectangular copper wire wound over soft iron core. Student, this armature or rotor is free to rotate about its axis. This is the axis of this armature or rotor. Now student, the function of commutators they changes the direction of flow of current through the coil each time when it passes through the vertical position during each revolution. So student, each time when the rectangular coil or armature passes through the vertical position, commutator changes the direction of current. Now student, brushes the current from the battery passes through the coil the current via carbon brushes. Student, these carbon brushes remains in contact with the commutators. These brushes remains in contact with the commutators Now student, when the coil rotates, the brushes remains in contact with the commutators. Student, see, when this coil is connected to this battery, current will start flowing like this. This is A, B, C, D. Now students, see here, we can apply Fleming's left hand rule to find out the direction of the force acting on the arms. Students, see, arm AB is carrying current in the upward direction and magnetic field is along this direction, and it is carrying current in the upward direction. So magnetic field is exerting force on this arm AB in the inward direction like this. Let it be F1. Similarly, student, the force acting on arm CD, it is carrying current in the downward direction, magnetic field is along this direction, so force is acting in the upward direction or out of the plane of the board. Now student, these two forces are equal, opposite, and they lie in different planes, so they tends to rotate this coil, and student, this coil will keep on rotating due to the current passing through the coil with the help of carbon brushes. Now student, let's discuss about the working of electric motor in detail. Student, now we have to discuss about the working of electric motor. Student, see here we have three figures A, B and C. Student, we know when two opposite forces act on the opposite sides of the rectangular coil, which is armature, that forces keep on rotating the coil continuously. Now student, let's see how these forces rotate the coil. Student, see in figure 1, these are commutators, these are brushes, and this is connected to the battery. Student, current is flowing in the armature ABCD. In arm AB, current is in the upward direction, and in arm CD, current is in the downward direction. Student, using Fleming's left hand rule, we can find out the direction of force. Student, this is the direction of magnetic field from north to south. Direction of current is in the upward direction, so force is acting in the downward direction, like this. Similarly, student, the force is acting on arm CD in the upward direction. So student, this will rotate the rotor or the armature anti-clockwise, like this. So student, this armature will rotate along its axis in the anti-clockwise direction. Student, in this case, in arm AB, current is in the upward direction. In arm CD, current is in the downward direction. Student, force acting on arm AB is in the downward direction, that is inward, and on arm CD in the outward direction. So student, it will rotate anti-clockwise. Now student, after half rotation, the position of coil is somewhat like this. Now student, in this case, each brush is in contact with each commutator segment, student, like this. So student, in this case, current bypasses the rotor, or it will not move through the armature. Student, through the armature no current is flowing, so in this case no force is acting on the coil. But student, if no force is acting on the coil, then how will it rotate further? Student, we have discussed about motion, inertia of motion. Student, we know if an object is in motion, it cannot change its state of motion on its own. So student, here also, as in the previous case we have discussed that force is acting on the rotor, due to which it starts rotating. Now after half rotation, though no force is acting on the armature, but still due to inertia of motion, it will continue to rotate. And now in figure C, rotor has turned 180 degree. Now student, in this case, CD is along this side and AB is along this side. Now current through arm CD is in the upward direction as shown in the figure, and in arm AB it is in the downward direction. So student, on arm CD now force is acting inward, and on arm AB now force is acting outward. So student, this armature will keep on rotating anti-clockwise. Student, in this case, in arm CD, current is in upward direction, and in arm AB, current is in downward direction. And force on arm CD is inward, and force on arm AB is outward. So student, it will again rotate anti-clockwise. So student, this rotor keep on rotating anti-clockwise as battery is supplying current to this armature and it is placed in the magnetic field. So as it is placed in the magnetic field and it carrying a current, so student, it will keep on rotating due to the equal and opposite forces acting on the opposite sides of this armature. Now student, similar case arrived after 180 degree. Now student, again this position comes when the rotor has turned through 90 degree and again no current is passing through the coil. But student, due to inertia of motion, it will not stay in this position longer. Due to inertia of motion, it will come to this position, that is A. Now again, current is flowing through AB in the upward direction and through CD in the downward direction. Now student, this process continues and the motor keeps on rotating, or this rotor keeps on rotating, and student, we can see here that this battery is providing the electrical energy, and by the motion of this rotor we are getting mechanical energy. So student, this is how electric motor is converting electrical energy to mechanical energy. Now student, we can enhance the working of electric motor. How? Student, we can use electromagnets instead of permanent magnets. We can also increase the number of turns. We have discussed that this armature is consist of copper wire which is wounded over soft iron core. So student, instead of just one turn or two turn, we can increase the number of turns. We know that more the number of turns we use, more will be the current flowing through the rotor. So students, so far in today's lecture we have discussed about the force experienced by a current carrying conductor placed in a magnetic field. Student, we have also discussed about electric motor. Student, in our next lecture we will discuss about electromagnetic induction. Thank you so much.